Automation is critical these days. We need to automate tasks and processes and design standards. We need to automate the creation of design documentation, manufacturing data, sales proposals. And you know what? With design automation for Inventor, you can do any of that. And there is a team at Autodesk that can help you build this automation. My name is Natalia Polikarpova, and I'm part of that team. It's called Developer Advocacy and Support at Autodesk. We're 100% focused on helping you with your software development efforts. When you build your apps, your integrations, your plugins, for our desktop products like Inventor, Revit, 3ds Max, AutoCAD, many others, and we support that through Autodesk Developer Network, ADN, and also for the cloud and web, which is Forge. And my role is business development for North America for both Forge and ADN. I have two co-speakers with me today, Sam Taum from Technip FMC and Kivac Izeldemir from Codo. They will be showing their solutions with design automation for Inventor. These are our learning objectives for the class. And I know getting started building your automation apps may be challenging, but you're not alone on this. I encourage you to learn from those who've already been doing that, from our customers, from our partners, from Autodesk community. Learn and connect with our support team. Connect with us before you build your application, while you're developing it, and when you start running it. When you connect with us, you'll be able to get going much faster. It will be easier for you to build these apps. And you'll be able to validate and optimize along the way as needed. For those of you who are new to design automation and probably Forge, let me give you a quick 2-minute introduction. What you should know is that design automation is part of Forge, and Forge is our cloud-based development platform. It's really about liberating data from over 70 different file formats, and not just Autodesk, but really any key industry formats to make your design engineering data easily available through the web, through the cloud, so that you don't need to have CAD software on your machine to access these designs. You don't need to share files around to make modifications. And you don't need to be a CAD expert to navigate these complex engineering models to have these valuable insights or necessary information. You connect your data with the people outside of engineering throughout your whole company, from manufacturing to procurement, from sales to servicing, getting the real value, spreading the real value of your design engineering data throughout your whole network, throughout your whole ecosystem. Maybe you want to build digital twins. Maybe you want to integrate with ERP, PLM. Maybe you want to enable automation. We at Autodesk actually use Forge to build our own products. Fusion 360, BIM 360, that means reliability, security, performance, not only for Autodesk products, but look at this number, over 3,400 monthly active developers using Forge day in, day out. And you're welcome to be part of this community. Forge is a platform. So design automation is just one of many components. For example, the viewer is a component that you and your customers see, first of all, to view your 2D data, your 3D data within a browser. Then there is another component, model derivative, that actually prepares your files for viewing, and it extracts metadata. So what you see on the web, it's not just geometry and textures, but really the product data that you need, parameters, attributes, bill of material. Or another component, data management, to manage files around, or BIM 360 and Autodesk Construction Cloud Platforms APIs for the construction apps, or webhooks notifications, and more. And you should expect this platform to continue to grow because we have more of these components internally. And when they're ready, we share them with you so that you can mix and match them to build a variety of solutions. Now, design automation. So think of it as running your CAD engines in the cloud. Your headless version of Inventor, AutoCAD, Revit, 3ds Max, Civil 3D, running in the cloud, and you can batch automate tasks. You automate the most repetitive tasks, the tasks that require a lot of processing power. On a very high level, how it works, the first thing you have to do is to make your data available in the cloud. It may be BIM 360, it may be Google, maybe Dropbox, maybe your own cloud, doesn't really matter, as long as you specify where this data is, assign URL, and give us permission to access it. And design automation is really about inputs and outputs. So once your job starts, so Forge pulls that data, runs your code, runs your application, might make some necessary updates, changes, and then uploads the results into the location that you specify. After that is done, we completely clear out the machine, and we don't have the knowledge of that data anymore. Design automation is really flexible. You can automate just about anything. And these are the key areas that we see partners and customers use to build their applications with design automation. But the most important thing, again, think about of taking your CAD data and making it available outside of engineering. Spreading the value of the CAD data that you already have throughout your whole company, your whole ecosystem, making a real use of it. Now let's see how our partners and customers actually do that. We start with Codo. Codo is our Forge system integrator, and they have a variety of configuration products. This is one of their recent projects.
This is a custom solution we developed for our UK-based customer, Kingsley Plastics. It's a time saver, it's integrated with our client's ERP system, so we can call it as an error saver as well. The kiosk configurator enables the salespeople to build custom projects, and it pushes the project output to the ERP system automatically. This automation cuts the repetitive tasks in the sales department. Before the automation, there were Excel spreadsheets with no integration, and this means a lot of manual work to do. You can guess that the manual work always comes with some human errors, which are really painful at the later stage. The kiosk configurator is a game changer at that point. And yes, this is the kiosk product that is manufactured by the Kingsley Plastics. The doors can be custom sized or standard. The custom doors may have various combinations of door locks, door stays, removable thresholds options. All these custom or standard components can be placed almost anywhere on the kiosk. As you see, the product parameters are extremely flexible, and its configurator has to provide the same flexibility to the users, and we did so. You can build base kiosk designs by selecting structure rules and entering dimensions. The kiosk configurator includes door configurators, and it also uses extremely easy method to add and position a component on a wall. The configurator is able to automate the cost calculations by generating the BOM data and reading the unit costs of the materials and components from ERP database. You can also download the sales drawings to present the project to the customer or send the project details to the design department. As a last step, with a single click, you can create a new project in the ERP system and push the bill of materials data into the project part. Now, the salespeople of the Kingsley Plastics can output the quotations from ERP software automatically. Here are the Forge APIs that we used in this project. We used Autodesk Inventor to model the kiosk designs, and we programmed them by using Inventor API, and then we generated dynamic logic libraries to run with the Forge Design Automation API. All the interactions you will see in the demo was built by using Forge Weaver API. And also we used Forge Design Automation API to generate the BOM data and sales drawings. Alright, now it's time to see how it works. Yeah, so this is the main page of the kiosk configurator, and we've added some tutorials for new users. Let's log in. Gonna authorize the user. So yeah, configurator comes with the parameters. So these are the main parameters, and we have door configurators to generate custom doors, and we have commands to add and edit or delete the components on the walls. Let's see the top view, and I'm gonna change the length parameter, gonna change the width parameter and height parameter. I'm gonna select manual joint and enter each wall length just like that, and generate the kiosk. Updated. So let's view the top and let's see the grid plan. I'm gonna see the standard doors on the list, and I'm gonna configure a single door. We'll change the door leaf parameters and add some lock options and generate the door. Generated. And I'm gonna save this custom door to the main configurators door list as custom door 1, and I'm gonna select by door to configure. Gonna change door leaf width and height parameter and add lock options, select rubber seal and generate it. Done. I'm gonna apply the same process to add this custom door to the main door's main configurators wall list. Yeah. So let's go back and see the custom doors comes here. Gonna select custom door 1 and click on A1, A2 wall and position it. Gonna select a double door, a standard double door, select on the same wall and set the right distance. I will add a custom door 2 on A1B1 wall and center it. Select a vent, click on the wall and set the parameters. Just like that. And set the left distance as 1 meter. Add another vent. Set the left distance and the button distance is 500 mils. Select another type of vent, and I'm using the edit tool to change the position of the edit components. Select the second one and set the button distance and write distance. Yeah. I am going to add a vent on B1C1 door and add another door on it. Single door left. I'm gonna set the left distance. It looks okay. So click generate button. Yeah, it's updated. This update procedure also generates the BOM list. Let's see the quantities. Let's see the unit prices and part prices. And let's see the updated drawings. Done. We can export it as a PDF document. Open it up, and this is the first page, and each walls has separate drawing sheets that represents the component layout with the distances from the boundary of each wall. Yeah. It looks well. By the way, you can view the wall names on the title blocks. Let's go back to the configurator and push this project to the ERP system. So this is the unique number, and we're gonna add a description, AU demo project, and gonna hit the create part button, and it compares the BOM list to the ERP database, and it found some missing parts on the ERP systems. I'm gonna search the project code and yeah, this is the BOM list that we pushed from the configurator. Well, thank you for joining us today, and feel free to contact me via LinkedIn. Have a nice day.
So that was Codo and their recent project with design automation for Inventor. And it's interesting, you know, these configuration type applications, they tend to engage your customer more closely with your product because they're already kind of building these configurations. And you get to choose the right customers to deal with, not just with any of those wandering around, but really those who are making these first steps of doing business with you. And your teams, your engineers, focus on most creative, most sophisticated, advanced tasks, rather than on something that can be done or should be done by a machine. Now let's look at another perspective, our customer's in-house application, Technip FMC.
Hello everyone, I'm Sam Taoum from Technip FMC Group, Flexi France. I will talk today about design automation with Envator Forge, a new flexible pipe and fitting configurator. First of all, I'll present myself, and then I'll talk about Technip FMC Group and Flexi France company. About me, I'm Sam Taoum. I have a PhD in applied mathematics and numerical simulation. My job is a numerical simulation development engineer. My mission is to develop and improve a numerical simulation and software solution from several fields, physical fields. Technip FMC. Technip FMC is a global leader in subsea, offshore, onshore, and FlexiFrance is a company from Technip FMC Group to product and manufacturing the flexible pipe and fitting. So Technip FMC has 37,000 employees from several nationalities and several countries. I will talk about our project or our case study in this presentation of this topic. So the idea of our project is to investigate a new solution, new software for to automate the design of various parts to configure the design of end fitting flexible pipe in 3D and 2D. For this topic, we create a new configurator called FNA3 that from some data, some information, or some BOD, basic of design or input. This input can be, for example, a number of structure flexible pipe, some load, the option also. So from this data, we can configure the design. We communicate with our database. We can get all part need for this design, and also we get, after calculation of this flexible end fitting flexible pipe, we get all parameters, and with this parameter we can configure the design in 3D, and from 3D design we automate the drawings for all parts in 2D for manufacturing issues. So our goal is to have a configurate that the configurate output will be ready for supply and manufacturing, and also that the implementation of new design in the future or modification design in the future will be faster and easier to maintain and to benchmark. I will share with you our roadmap, our work roadmap. Actually, we started in November 2019 with a 3-month of POC, proof of concept, with the support of Autodesk in France. We had 10 days support with Autodesk between November and January 2020. And with these 3 months, we get all information about how to communicate with the Forge, how to communicate with the cloud, how to create buckets, communicate with the Envator, etc. We also get or used a sample, an example from the Autodesk forum, and also from GitHub. So we started in July 2020, and in 15 January 2021, we get the prototype 1. 2021, 15 July 2021, we get prototype 2. And we are now in 15 October 2021. And we have a version 1 of this this configurator. Now I will talk about the configurator, how it's work, And also we give you an example of this configurator. So how it works with FNAI3? The customer, depending on physical information or other data loads, for example, the tension, the deep water, etc., can configure its design. So FNAI3 soft is composed into two executables. The first one is the main executable of FNAI3, or the graphical interface of FNAI3. It's made with Delphi language or Pascal language. This main executable has also the all calculation of the end fitting. It communicates also with our database, engineering database. So from this information of the user, we can get from our database all list of part needs for this design, and also the shop part. And also with this information, we can do some calculation of the end fitting, and after that we can get all parameters to make the configuration of the 3D design. So all this information of list part, part shop, and parameters, we send all this information to the cloud by another executable in C# language. And after this information sent to the cloud, and the automation will be done in the cloud, and after that we get all CAO output, and we send this user. Now I will present here a design selected, and after that I send all information to the cloud, and now we can see a viewer HTML language, the output of our design from the cloud directly. So we can see all shop part also. We can see here the list of shop part, the number of each part, and also the description of this one. We can also see all properties of each part, description and properties. Here we can cut or do a section analysis, Z section analysis, to see the model of the end fitting, all part in the middle section or Z section. We also, our focus not only in the 3D, but the idea or the goal of FNAI3 is to get a full 2D drawings automation. So as we see here, we get all 2D drawings of all parts with several languages, and also full drawings for manufacturing issues. How it's functioning, this configurator, and with this functioning of the configurator, what are the benefits of using cloud? So as we see here, we are working in our inventor in our computer on local working. So in our computer, and with this local working, we can make a template of each part. So each part has one template with the configuration. This template, the shape of the model, 3D model, can change and to make or change the design. So one template for one part, and each template can change the configuration or can change the shape to change the design. We use also a to make the configuration in 3D and 2D a several code in VB.NET code, and this code VB.NET and all template in 3D and 2D drawings will be sent on our storage in space in Platform Forge. So how it's working, each user can change, as I explained before, each user can choose the design, and by this information, the parameters, list part shop send or will be sent to the cloud with a TXT transmission file called transmission file. Is a TXT file, and the user can get the output of this drawing or this design immediately and on spot, depending on its need and its configuration. So what are the benefits of using cloud? So as we see in the functioning architecture of this software, no local installation of Inventor on user computer. We use cloud, so we don't need to install Inventor on each user computer. So we are communicate in the cloud. The configuration is done in the cloud, so no need to local installation. The second is this methodology between 3D and 2D allow us to its speed to integrate a new design and implement a new modification. So the designer change the shape in 3D, and with this code, VB.NET code, but actually we have a drawing automation. So from 3D to 2D, it allows us to integrate a new, faster, new implementation and new design. The third one, it's the most important for us, it's to accelerate the time between the drawing correction and the engineering offices. Actually, in Technip FMC is a big company, as I explained before, and we have several drawing offices in several countries, in France, Brazil, Houston, UK, etc. And also, we have a big gap between difference between each engineering offices. So to reduce FNA3 with using cloud allow us to accelerate the reduction gap between these drawing offices. How? Actually, we by communicating with each other, we want to make a modification. So to accelerate this modification, actually, as I explained before, we are working in the local Inventor, and after make this configuration, this modification, sorry, actually it's very easy to make the correction for all Technip FMC user by send this modification to the cloud. So with this using of cloud, this methodology, we can reduce the gap between our drawing offices by accelerate the modification and the update on the cloud. Finally, I want to say thank you. If you need or have any question, I will be ready. Thank you.
So that was Technip FMC and their project using design automation for Inventor, actually using Inventor and Forge and iLogic with all these modification changes for their offices across the globe. So these are the two examples we wanted to share with you. Now let's focus on how do you actually get started. For your software developers, there are several options. If they prefer to learn individually, they just go to our online tutorial, learnforge.autodesk.io, and they can just go there. Or if they need help from our Forge experts and they prefer to learn at the training, they can do that. They just need to go, and this is one of our recent online training. There's also detailed documentation that you can have all the necessary information. A very important part for Codo, for example, when they started developing on Forge, their first coding experience was to join our accelerator. This is 1-week program, and we run this accelerator almost every month. So if you want our experts' help and really working together on helping you with your prototype, with your first proof of concept, or just to advance your project, join us for the accelerators. Support help, standard support is Stack Overflow. If you have something private you want to talk about, you have questions about, just send us an email, forge.help@autodesk.com. We made it easy to connect with us. You can schedule a call with our engineers. Just choose the right time zone, choose the right component you want to talk about, APIs. If you don't know who to contact, just send us an email, forge.help@autodesk.com. And another important thing, we would love to have you at our Forge coffee breaks, very informal gatherings when just come together and just share some updates, new code samples, what you're working on. You can hear from others what they're working on. And that's a very good way to actually catch up what's going on with Forge. Our Forge system integrators are the right partners to actually work with when you're just getting started with your Forge projects, just like Codo. I also have a few useful links for you in the presentation, in the handouts, about Forge pricing, how you start trying Forge for free, subscribing to Forge, managing your costs. There's a new cloud credit calculator that you can use, and there's a lightning talk about that, so don't miss this. Again, more useful information about optimization in the Forge blog, and how to make your configuration results faster. And there's a lot of new content coming to the blog all the time, so don't miss that. If you want to learn more about Forge, not only automation, but really about visualization and digital twins, AR/VR, parts catalogs, there's lots of videos available on YouTube, so you can learn from there. And finally, our gallery of code samples. So both Technic FMC and Codo, they use our code samples to really get going much faster. Because imagine doing something from scratch when you can really, focus on your customer needs, customer requirements. And these are not just examples, but real code samples that your software developers can use. You just go to the GitHub, find Autodesk Forge, and you have all these, code samples that you can use. With all of that, I'm pretty sure you have some interesting ideas what you want to use with design automation for Inventor. So I encourage you to learn more. Go to forge.autodesk.com today, start your free trial, talk to your team, and connect with us. When you do, you'll have this confidence to actually get going faster and easier. You'll be able to validate and optimize your applications. After all, it's never too late to automate. Thank you.